All right, folks. Thanks for coming back. I'm afraid the table structure video hasn't been created yet. I apologize for that. Hopefully I'll get around to doing it sooner or later, before the end of the term, at least. Last week we took a brief detour through database permissions, roles, grant, revoke, certain super users, what you can do with permissions on a database. We also looked at the very, very common relation types and the table structures to match, so one-to-one, one-to-many, many-to-many. And then we spent the last 2 minutes looking at transactions and ACID principles. So this week, we're going to be running some queries during the workshop, of course, which is why I hope some of you have the VPN running. And then we're going to look at doing stuff with single tables, some joins, some functions, and then we're going to look into the various different types of joins and how you can use them to your advantage. So before I'm going to let you guys loose on the sandbox, I'm going to show you some very, very basic queries you can use to navigate your way around a database. If you're going into an unfamiliar environment, these queries will help you find your way around the tables. It's very, very important to be able to instantly try and, I guess, map your way through an unknown database. If someone doesn't have the time to tutor you in it, then you're going to have to make your own way, essentially. You can use pgadmin to list various objects in the databases, so the schemas, the tables, indexes, sequences, functions, basically any object the database has, pgadmin should be able to show it. In some cases, that's a very, very slow and painful process. So you can expand, if I go to pgadmin here, come on. You can see we've got everything that you create in the database whenever you create a table by default falls under schema public. Then you can see we've got 6 tables, address, category, and so on. If you expand these, you can show the columns, constraints, indexes, and so forth. Doing that per table every moment you need to find out a bit of information is a pain in the butt. So personally, I wouldn't. It's good if you want to find out the names of tables. You can also do the same with the autocomplete in pgadmin, which is a naive autocomplete. It's not context sensitive, so you can start writing a query like select all from, hit control space, and it will show you a list of tables and sequences that you can select from. Quite why it includes sequences and not functions is beyond me, but there you go. Once you've got the actual name of the table that you want to look into, you've got those 2 queries at the bottom there which can actually show you the structure. So you've got select all from table limit 1, which will bring back 1 record. Again, the limit keyword is fairly self-explanatory. Very useful if you're working in batches in an application. You want to limit a processing batch. And then you've got the second query there. Any query where the where clause evaluates to false, which that clearly will, is going to bring back an empty result set. But the point is it will always bring back a result set, because technically there are no rows that match in the table. But you do get the structure. So an example of that would be if we were to so there you go, you've got the names of the columns, but you got no data. That's essentially what it does. Come on. You've been introduced to a fair bit of SQL in the lectures, I'm guessing, for people still doing the lectures. Success? Excellent. So I'm going to start with possibly one of the most useful and most powerful keywords in SQL, which is select. You'll see a lot of people using select with select all, or select a few names, and then continue with this standard generic query of from and where, blah, blah, blah. Select can do a hell of a lot more than that, and a lot of people that's not really conveyed during the database lectures. So select is essentially used to display information. Doesn't matter where your information is coming from, as long as you've got that information somewhere, select will bring it to you. You can use select to display all sorts of things. You don't just have to use it with tables. So I'm going to run a particular query, which is valid SQL. So valid query, job done. So you can put in a calculation into select and it will spit out a result back at you. Obviously you can run this loads and loads of times, no one's going to expect it to change. But there is an interesting result from this, and that is the name of the column. How visible is that? Not very. The name of the column is question mark column question mark. The reason for that is that we've given the database something to calculate. It's not something that's already been named. So any kind of calculation you have like this, where you start doing mathematical functions or unnamed functions in the query, it's going to spit out that generic name back at you. So to fix this, we use aliases. So we add as to select our alias, and then we're just going to call it calculation because I'm boring. And then that's given the result set the name of calculation. Whenever you're connecting to databases from applications, you will have to alias static parts of queries like that, because otherwise you won't be able to refer to that field in the result set by name. You would have to do it by the position of the field in the set, which is generally considered bad practice. So, rule of thumb, always alias anything that doesn't come back with an automatic name. Next thing we can do is we can take advantage of some of Postgres's inbuilt functions. Almost every database that you use or come across will have a built-in set of functions which you can apply to various different bits of data and transform them or morph them around in various different ways. So the first one I'm going to pick, there are so many, I obviously can't go into detail for all of them. If there's something you want to do in a database, have a quick Google around. Chances are there may well be a function to do it for you. All of the common ones like substring, length of string, pattern matching, time and date, they're all in there. So now is the current time and date, which is a timestamp with time zone. So in ISO format, so date, time, milliseconds, time zone. And then every internal function will be named after the function. So the name of this column in the result set is now. Another example is a string function. The function to transform something into lowercase. Oops. So that's fairly self-explanatory. It's taken our input text, which was this is uppercase, turn it into lowercase, and it's lying to us. So obviously this is just a demonstration of what you can do with functions. There are other functions which will actually make modifications to the database rather than just taking a value and spit out something different. But we'll go into a bit of that later. Next up, standard queries, as we mentioned earlier, where we're selecting from a single table. It's very, very boring. You'll get to do that in a minute. You've already done it at the practicals. But we're going to go into modifying the database because that's where some interesting things lie. Oh yeah, that's that thing. So insert and update, this is where things can get a little bit messy. You've covered insert and update statements in the lectures, so you know roughly what they do and the rough syntax of them. Keywords in the example are highlighted because I was feeling nice. So you can actually do a lot more than the lectures originally tell you. So for instance, you can see here, we've got an insert statement, the start of one, and normally what you might see is you'd have values and then a comma delimited list of pairs, tuples, whatever, to insert into your table. What you can do instead actually is pipe the results of a query into the insert. So if you want to duplicate data in a table or transfer data between tables, all you have to do is slap a select after the insert and jobs are good. Same goes with update. You can build a result set and shove it into an update query. So if you had a bunch of tables that you were joining together, you needed various different values from them to update this one table, you would build your from list with the joins and then just use the various aliases that you've created to set the fields as appropriate. Very, very, very powerful what you can do. Again, all of this is captured in the documentation, which if you want to know more, I would encourage you read. And I hope to give you some examples of update from and so forth, because they actually do get used to a reasonable amount. Okay, so just also to explain, this keyword here, I like, is unique to Postgres. Like you may have already seen is pattern matching. Typically on strings, the I stands for ignore case. So this is a case-sensitive match. The percentage is a wildcard character. So that's where we're looking for the product in the product table where descriptions start with golden, ignoring case. So that query there, the insert, will duplicate that row in the table because we're only inserting into the same table. This, of course, means that you can put basically any data into that select and pump it into the same table. This can include functions, so as is suggested a little lower down where it says set forename equals lower forename, you can use functions, of course, because it's a select. So if you need to transform your data or manipulate your data before putting it into the table, functions. Okay, so this is the point where you guys actually get to do some of the stuff, because enough of me talking. Who isn't connected to the VPN? All right, folks, we're going to have to forget the VPN. So, pick someone from the crowd. Let's pick Dean, because he's not here. All right, so I want you guys to shout out what you want me to type. You guys are going to write the queries for me. First of all, we need to insert a new category into the category table. So, who wants to shout something out? Come on. I'll start you off with the word insert. And why is this going slowly again? All right, any takers after insert? There we go, into. Next. Yep. Anything else?
So is category already there?
Yes. Yep. The category is a table.
That's like predefined syntax.
No, it's the table name.
Oh, so you're creating a table.
No, we've created the table. We need to put a row into it. So after category, any ideas, suggestions, thoughts? You do. What fields do you want?
I don't know, what fields do we have?
Good question. Every time it does this, my mouse just...
So the star, what is that?
Select all.
Okay.
Oops. Well, that'll do. That'll still work. Right, those are the fields you have available. You've got ID, description, and created at. Take your pick.
Do I have to, can I just say like category star?
No.
I have to go in and define it?
Yes, you can. You do that by not specifying any fields and brackets.
Oh, okay, cool.
And you just follow that immediately with values or a select.
Oh, okay, cool.
So, in the interest of time, I'm going to spoil it for you a bit. The ID column and the created at column are automatically populated. The ID is an auto number and created at is just the current time. So I'm just going to go for values. And then someone give me a name of a category.
What are these categories for?
Products.
Can you, instead of writing 12 equals 2, could you write false or something?
Let's try it. Should be able to. Any Boolean statement that will evaluate to false should give you the same result. Yes. So we're going to insert books into categories, or categories, sorry. There we go. Done. Right. That's that bit. Okay, I want you to find all of the products that have a product type of interplanetary destroyer. Everything exists, so you can assume that it all exists.
Okay. So do we have a product table?
Yep, you've got a product table.
So select.
Yep.
Star from product.
Yep.
Where.
Yep.
And was it then
The
type?
product type is interplanetary destroyer.
Yeah. I think, yeah, can you not just do open round brackets, product type? No, just do type. Well, it depends on the field that the column.
I have filled in the correct field name, but this is going to break. And I'm going to run it and show you how it breaks. Sorry? Nope.
I can't remember the syntax. It's not cool or something.
Invalid input syntax for integer. Product types are stored in a different table.
Oh, okay.
So to complete this query, what do we need to do?
Well, I was going to go and look up product type table, find it to planetary destroyer
There you go. But that's not quite bad. It's that you shouldn't necessarily work with raw IDs.
Yeah.
So we're going to alias that. We're going to join product type. And then we're going to change. God, this is so slow. Unbelievable. There we go. And then we've got to change this to description. This is probably not going to work. Probably. Oh, would you look at that? So that's that simple join. That's the one-to-many that we showed last week. Unfortunately, in the interest of time, I have to just abandon ship on running queries for the moment. I'll publish or try and publish a list of queries or edit the video. Sorry? Yeah. I'll try over this week. I will try and either assemble a VM or assemble some scripts so that you can install Postgres yourself, get the database running, and just run the queries straight on your machine.
Yeah, so is there a way that, you said that we have to have it running at the same time as your...
You don't have to have it running at the same time.
No, like you have to have...
For the sandbox, you do.
So what's that? Like, so can we still just like do all this stuff in our own?
Yes, but you'd have to set up Postgres yourself, and I'll give you the scripts to recreate this data. Okay, so let's take a look at the various different types of join we have, because that's the last thing I wanted to cover today, and I'm going to try and motor through it in 10 minutes. Right. So these were some of the things that I tried to get you to do. So we saw that we were looking for a particular product type and the products that were of that type. I've made a couple of tables in the telecom database, test 1 and test 2, to try and illustrate the various differences between the joins. You have, for most part, that you'll see in industry, you'll have inner joins and outer joins. Inner join is just one type. If you type the join keyword without inner, most databases will assume that you mean inner join. An inner join is the equivalent of an intersection in set notation. Let's see if I can get this to work like last time. Outstanding. So you've got set A on the left here, set B on the right. You've got epsilon being all members of all sets. When you're doing joins in SQL, the left join is the table that appears further up in your from statement. Right join is the table that appears further down. So a left join is just this set here. Right join is just that set here. Inner join is the intersection between them. And outer join is everything. Sorry? They don't have that?
No, that makes a lot more sense.
Fantastic. Oh, well. So, yeah, left join, as I said, set A, right join, set B. Full outer join is the union. You can filter, when you're joining between tables, you will get disjoints. You can filter on nulls, which are created when you have records that don't match, to try and find records which aren't in one table that are in another, for instance. So if we had a category that didn't map up to a product, we could do a left join or a right join onto that table and say, okay, if this is null, where this particular column is null, that's where we've got a mismatch, and there is a category that doesn't have any products in it, for instance. Something important to note when you're doing joins, the on keyword can use any Boolean statement whatsoever. So the very pedestrian one is field 1 from table equals field 2 from other table. But actually you can do some filtering in the joins. There are good and bad reasons for doing this, but we'll get into that in the efficiency talk in a couple of weeks' time. You've got unusual joins. The Cartesian or the cross join is every row in each table multiplied by every row in each other table. If I see anyone doing this except for experimenting, I will hack your legs off. Mostly because on very big tables, it will bring a database to its knees. Natural join, again, is not something you tend to see used very often. It requires that you have common column names in between a table. So my convention for creating tables is, for the primary key, I'll just call it ID. Some people will call it table name underscore ID, and so then the foreign key and the primary key are the same. If they really wanted to, they could use natural join, but I would slap them with a halibut if they did. You've also got in Postgres join using, which is similar to a natural join, but you can actually specify the exact columns which are the same in between the tables. Again, very, very rarely used. So just to drive the point home a little, let's have a look at these tables in the Telecom database. So that was just me doing some fun. This is why cross-join is messy. I was just messing around. So there's behave. Oh, wait, of course. Third time's the charm. There we go. So I only have 1, 2, 3 in one table and 3, 4, 5 in another table, and already you can see it's created 3 squared, which is 9. Never do cross-join, ever. Please, I beg you. This is going to be an inner join, and it's going to show you all of the records which are the same, which is just going to be 3. There you go, exact match between table. If we turn that into a left join, you will see everything that's in test 1 that's not in test 2. There you go. So these blank spaces here are nulls, and that's going to come into play a little bit later. If we do a right join, you'll get the same, but from the other table's perspective. So everything that's in test 2 that's not in test 1, no surprises. And then, of course, you've got full outer join, or actually in Postgres you can cheat and just do full join, and that just shows you literally everything that's in between the tables. So you've got, it will combine the rows where it can, so 3 and 3 match, but otherwise it won't. This is also what I was saying about finding rows that don't match up between the tables. If you check for where is null, you can see 1 and 2 are in table 1 but not in table 2. So that's the complement in set language. Everyone understand that, I'm guessing? Very, very, very useful. Almost always everyone will do a left join instead of a right join just because it follows the natural flow of the query. And again, if you can't guarantee that something's going to be in a table, just left join every time. Come on. Oh, is that the end? That's the end. Cool. Any questions?
When you were selecting it and then when it was only running the bit that you selected?
Yeah. A common pattern among IDEs and general kind of query editors and environments is that it will only run the selected text. Right, since we have a little bit of time, I can show you some queries which I tried to write, which I was going to try and get you to figure out, but now that I look at it, it might be a little bit evil. I have a table, the CDR table, which has 10 million rows in it. All of them have call records for particular people. And I was going to ask you guys to work out how many minutes a customer had used. That would be accomplished with this query. So you don't have to worry about the interval 1 second bit. That's basically just to make it look pretty. You can quite happily just do some duration. Again, just string match and on the where clause. Very, very simple, nothing too adventurous. But it being a 10 million row table, anyone want to guess how long it's going to take, bearing in mind it has to match on a string? Any takers? Minutes? 30 seconds? Under a minute? Right. I'll bet someone in this room that's going to take less than 2 seconds. No takers? 240 milliseconds. This, I suppose, is a bit of a precursor to next week's workshop, which gives you the benefit of indexes. So even though we have 10 million rows in that table, it knew exactly where those 2 were that it needed to sum up. Job done. There you go. If that wasn't indexed, I would hate to think. I don't want to drop the index and test it because it will take a while to. It may take us up to the end of the workshop. But actually, let me see if I can drop index IDX CDR. This is a bit where I can't remember the name of the index. Huh. Right, what I'm going to do first, I'm going to introduce this next week, but there is a wonderful keyword called explain, which will tell you what the query planner is going to do. Before, it would have done an index scan. This time it's not going to, and you can see the cost is 342,000. So if I run this now, it will, as Greg is probably right, will take minutes.
So what's that cost is what?
It's somewhat up. 2.4 seconds. I was wrong. It's somewhat arbitrary to PostgreSQL. I think it's in number of rows, but I'm not entirely certain.
Okay.
I naturally, before next week's workshop, when we look into the explain keyword, I'm actually going to have to do some digging to find out exactly what means what, because I only have a vague inkling. But that's actually not as bad as I was expecting. I was expecting to take a lot longer, but 2.4 seconds is meh. Yes, it's a binary tree index. Most indexes and databases will be binary trees. Again, more on that next week. But that's about it. Does anyone have any questions? Demands? Sentiments they wish to declare? I'll try and get you guys... Sorry?
That should not have been that fast.
No, it shouldn't, should it?
Is that cached in RAM at this point?
Yes.
You've already looked it up once.
It will be, yeah. I don't want to restart it because it'll take forever.
Drop your RAM.
Quickly flush all the RAM. Cool.